This lesson for the Windows Passive Crossover Designer is for the crossover and target setup. This is for the actual acoustic target function that you're going to go for, and it is for the electrical crossover selection just for the primary section of the crossover. This doesn't include the other additional circuits that will come later that are the other tailoring circuits. To start off with, we have a section, this is for the section up here, these two on the left. We have the target transfer function and the tweeter high pass crossover selections and component values. To begin with, you want to have an acoustic target selection. There are two ways to do that. One is to use this select desired high pass type option, which allows you to go in and specify which kind of a target you want. And then over here you set the frequency and then the dB level. The other way to do it is to import a pre-created and saved high-pass target that needs to be in an FRD form. So we'll take a look at both of those. To begin with, the primary one that most people will use, the main one that would be the select desired high-pass type. These have a list of options that you can select anywhere from first order Butterworth, second order Bessel, second order Butterworth, second order Linkwitz-Riley, all the way up to sixth order for all of them, or eighth order for the Linkwitz-Riley itself. The target used in this particular design was a fourth order Linkwitz-Riley. The frequency center was 2000 Hertz and an 83 dB level. If you go over here to the screen and turn on the target, you'll see the overlay with the actual acoustic response of the current point of the design. You can make changes to this easily just using the scroller wheels. Slide it up and down, and it adjusts. The screen adjusts automatically depending on the range of the data that's on the screen. So it's going to probably always jump to this particular display level when doing this. So you can slide it up and down or enter numbers directly. It works really quickly, easy to use. dB level, slide it down and up. Works quickly. If you want to try different crossover types, you can simply click on the option and then use your scroll wheel, and as you scroll through, it'll go through an order of each of those. You can see the target changing each time I scroll the wheel. It looks like there's a lot of change, and there is as far as what you see on the design. However, if you notice, the center frequency is still the same. Because of the variance of the variables in the crossover types, there's a lot of change in what you actually see. But if we set it to something such as fourth order Linkwitz-Riley, then switch to fourth order Butterworth, you see the slight change, whereas the Butterworth is only down 3 dB at the crossover at 2K. Linkwitz-Riley is down 6 dB. So if you take a look at the 2K vertical line, that's the crossover point specified at this frequency and according to the type. So the LR6 will be down 6 dB, or LR4, excuse me, will be down 6 dB there, and the fourth order Butterworth will be down 3. So you can see how it slides up and down 3 dB at that 2K crossover point. The other way to set a target is to import a high pass target. This will be from a file that has to have been created ahead of time. You can use any tools you want to. You could probably do things manually for a target, but if you have some unusual targets you'd like that are not listed in that pull down window, pull down option set, then you can create your own. You go to here in a case that I have of targets set up. Now in this case it's the same thing. I just did this as an example. So if you come in and look at the LR4 2K high pass FRD, double click on that, it reads in the file, and then displays it. The only thing to be aware of here though is if you make a change in either of these, any of these at this point, what's going to happen is it's going to revert to using this. At some point I'd like to change that so that you could adjust the dB level, but if you change the dB level at this point, it reverts to the section using the selected high pass. So be aware of that if you decide to import. Again, I hope that that will change in the future. It's not high on the list, but I should add that to it. The other section is, at this point in this lesson at least, is the tweeter high pass. In this case, circuit selections and component values. I'm just using the demonstration with a tweeter. What you do here is you select the high pass crossover order, and this is the electrical order, not the acoustical order. This is the electrical order. You can have first to fourth. When you select one of those, you'll see the graph change, but as well what you see here is this is highlighted in the first row. Each one of these rows adds an order. So as I scroll down and add second order, you'll notice each row becomes highlighted, which means it can be changed. Scroll up and down as much as you want. You can see the previous values. They just get grayed out and you can't modify them. So in this particular design, we had a third order crossover. Then when you come in to the circuits, what you can do is come in and scroll up and down, and you'll see the changes in the acoustic response. As you do that, manually set value. If you want to manually set a value, simply scroll, highlight it, and edit it. Put it back to what it was. And that's it for as far as the actual changing the electrical cross of the actual primary acoustic crossover. The portions down here not covered are these other topologies like traps in series or traps in parallel. That'll be covered separately. The one thing not working on this page, the only thing not working on it still, is this initialize textbook values. What should happen there will be if you would set a crossover frequency here, then you would say initialize textbook values, and what it would do is populate the electrical circuit with the default textbook values for that type of crossover. But that's the electrical equivalent, the electrical crossover circuit. It's unlikely, there'll almost never be a case, I should say, where the textbook values will be the actual final target values or design values you like to achieve an acoustic target, because this interacts with the electrical crossover interacts with the raw response and the electrical response, the impedance response, as you can see over here on this side of the driver, to give you the final acoustic response. So this is simply a starting point. So it's not overly important at this point, which is why I've got it on the back burner until I can do other things first. You can clear the crossover values just simply by clicking on this, but you can't recover it afterwards. There is no undo, so be sure that you really want to do that if you do that. If you want to see what the filter is doing, you can highlight the filter, and then as you make changes, you'll be able to see the filter change, and in fact you can watch the filter change and the corresponding acoustic response change. And that ends this lesson.